Hello everyone, welcome back to our channel. Now in this video we are going to understand what is dynamic programming, and we are going to have just the introduction here because you know to solve the actual problems you need a lot of time, and those explanation I'll be giving you separately when we are going to actually solve the problems on the same topic. For now let's understand what is dynamic programming and why do we need it. Okay, so why do we need dynamic programming? Let's understand with an example. Let's say I'm telling you to add 10 numbers and you have to add one by one to get to the 10. So you will add 1 plus 1, you will get 2. Again, you will do plus 1, you'll get 3. Again, you'll do plus 1, you'll get 4. And you'll keep on doing until you get 10. Okay. Now, after let's say 5 minutes, I came back to you and now I'm telling you to, calculate till 12. Logic that you have to perform is the same as the logic that you use to calculate till 10. Okay, now you can do this in two ways. Either you're going to start again from 1 2 3 4, right? So that is one approach and you will reach till 12. Or you know that you are performing the same logic again that you used to calculate till 10. So what you're going to do, you will know you already calculated till 10 and you are going to add 2 in that, right? You're going to add plus 1 and plus 1 again 2 times, so you'll get 12, right? So you saved a lot of time by knowing that you are going to perform the same logic that you used to perform earlier to get some different output. That is the same mindset or technique you can say we are using for dynamic programming as well. When you calculated a particular solution once, you don't want to calculate it again, right? Now that's what is called dynamic programming. What is dynamic programming? It is a technique of breaking down a problem into smaller problems, solving them once and storing their solution so you don't have to calculate that again. That's the same thing that is written here. Okay, you have a problem, okay, then you have broken down that problem into smaller problems, you have calculated their solutions individually, and when you're getting the situation when you have to calculate the same logic again, so you don't do that again. You know that this logic you already performed and you have a solution with you, so you don't perform that logic again and use that solution that you stored somewhere to continue with the remaining logic, and that's what is called dynamic programming. Now DP is also called an optimization over divide and conquer. There is a reason for it, because in divide and conquer you divide a problem into smaller problems, and in DP you are storing their solution to avoid recalculation. So let me tell you how this DP is an optimization over divide and conquer. So divide and conquer follows the pattern of optimal substructure. Okay, means you can divide the problem into sub problem to get the final output. Okay, now this is called optimal substructure. That is the property of divide and conquer. Now, when your problem already follows the optimal substructure pattern, right? That means your problem can already follow the pattern of divide and conquer. Then you check for one more thing, if your problem also has a pattern of overlapping sub problems. So in DP you look for two things. When there is an optimal substructure, that means it is already following a divide and conquer technique, and then there is a pattern of overlapping sub problems. That means basically there are problems for which you are doing calculations again and again. Now that is a pattern of overlapping sub problems. Now when you have these two patterns, right, optimal substructure and overlapping sub problems, that is when you know that you have to use dynamic programming here. Okay, as simple as that. Now here in dynamic programming you have two approaches, which is top down approach and bottom up approach. In top down approach, what you do, it follows memoization, means solving a problem recursively and storing its solution so that we can avoid solving it again. So in top down approach, what you do, it follows a technique called memoization. Okay, So there you make use of recursion. Basically, that's what we have written here, right? When the similar type of problem you get again, you avoid solving it again because you already stored the solution somewhere. Then and then comes the bottom up approach. It follows tabulation method, means solving a problem without recursion and store the result in a matrix. Again, this also following the pattern of overlapping subproblems, but here we are not making use of recursion. Okay, we are storing the solution in some 2D matrix or something, and that matrix we are using to avoid recalculation. Right, that is a very bare minimum introduction of dynamic programming. There is a lot to learn in DP that we can learn in problem solving. Not here for the introduction of it, but as part of this video, that's all I wanted to explain. See you in the next one.